Hey guys, Troy from Transformative Technologies Australasia. I am super excited to be here with James Garrett. James is the thought leader for Transformative Technologies Global for psychology and behavioral economics. And we're here to do a deep dive into his most recent article on Neuroplasticity 2.0, enhancing brain change. Welcome, James.
Thank you. Appreciate it, Troy.
Thanks for joining us, man. By way of introduction, I'm just going to go through give you our listeners a little bit more of a background on who you are, because you've done some really amazing things. So James is a brain hacker, brain coach, content creator, and the founder of Brain by Design. He's spoken on stages ranging from Harvard to TEDx, and his work has been featured by New York Times, Fast Company, Harvard Business Review. He built one of the only brain-based positive psychology curricula in the Middle East and trained thousands of Arab youth in partnership with HM Queen Rayner of Jordan. James has spent years doing research with some of the best psychologists in the world, including Walter Mischel at Columbia, of the famed marshmallow experiments, Mark Brackett at Yale Emotional Intelligence Center, and Stanford psychologist help me out with this one, James.
Nalini Ambady.
Thank you. His research on self-efficacy, emotional intelligence, and snap judgments has been published in top scientific journals. A rare combination of scientist, trainer, and entrepreneur. In 2019, James launched the Deep Change Project, a brain hacking journey to overcome fear through neuroplasticity. We might actually just start, tell us a little bit more about the Deep Change Project, James.
Yeah, sure. So the Deep Change Project was something that I kind of conceived of a year or two ago. And basically what I started realizing is this kind of skill set of self-directed neuroplasticity that I get to a little bit in the article is just that. It's a skill set, right? It's something you can learn and get better at with practice. And so for me personally, I was very familiar with the science. That's one of my world is diving into all the science, but it wasn't necessarily an embodied experiment, if that makes sense, right? This sort of idea of doing a sort of life experiment with an N of 1, with a sample size of U, right? I think is a very different way to think about how we do this kind of thing. So in general, right, when you're doing scientific studies, of course, you need lots of people science is all done on averages, based on averages and groups. But we're now, I think it's the possibility to do these sort of N of 1 experiments on ourselves is taking shape. And of course, technology and data and personalized data are having a big impact in that. So another way of saying that is one of the weaknesses, I think, of the scientific sort of approach is that it's because it's all done based on averages, individual differences get collapsed, right? So if you do an experiment, you do some kind of intervention and you move the average a little bit based on that intervention, and you show significance between those two groups of people. You say, in general, this happens with most people most of the time when we do this intervention, right? But of course, all averages are made of individuals. And so what we're trying to say is, how do you apply the science to an individual life? Because oftentimes when we look at the science, we say this predicts averages, but it may or may not predict you as an individual, as a unique individual. And so what I've been trying to do is carve a path by taking all the science, but then really trying this very extensive applied experiment on myself. I'm also trying to get out from behind the science, because I think it's easy to hide behind the science, and really taking on the kind of messy project of personal growth and development, and sharing that openly.
Well, it's a whole new lens that you're actually bringing to it when you're in the actual experiment yourself, because you get to experience the nuances that you can't see from the position of an observer. from the outside, but when you're actually inside that, there's so many subtleties and I find gifts that arise that you just can't be aware of when you're looking at it from the outside.
Yeah, exactly.
So I appreciate what you're saying. And I think then taking that into the broader experiment, you'll be so much more well informed about uh, what some of the potentialities might be for the participants of your research projects, more broader scientific research projects. Great stuff, man. I've been following along a little, and some really interesting stuff that you've been doing as part of that.
I mean, this year I'm interested in this question of fear, right? Fear is a very primal emotion, and I've been fascinated. So I'll just give an example. Like last week, I happened to catch a scorpion in my garage. This is completely random. I pulled out a box and there he was, right?
Wow.
So under normal circumstances, I would have seen that, tried to stay calm, but probably, tried to maybe catch it or whatever. But of course, it occurs to me because everything I'm thinking about is how to neutralize or overcome fear. The more kind of radical way to pose that question is fear erasable? Can you overcome fear, or can you make it so you can erase fear from the brain? I don't know if we can do that. My answer is probably not, but I still think it's an empirical question. I think it's certainly overcomeable, meaning fear freezes primarily. That's the first thing it does. We freeze first, then we flee, then we fight if we have to. That's Joseph Ledoux's formulation of it. So it freezes. You literally freeze when you feel fearful or anxious. This is, of course, relevant for coronavirus because a lot of what's happening with anxiety is we feel stuck, right? So I pull out the scorpion and immediately I freeze. But I'm wanting to become the master of that emotion instead of it being the master of me, right? And so I put it in a plastic bin, and and I'm trying to sit with the emotion and with the scorpion at the same time, right? So I'm not doing anything necessarily that's deliberately dangerous, although it could be dangerous. So there's risk involved, but it's controlled risk. So I don't do this at home, by the way. Not recommending this, but this is just I'm doing this stuff all the time where I get my hand down into the bin, maybe this far from the scorpion, and I just place it there, and the scorpion stops moving. Of course, the scorpion's probably terrified as well, right? And I just sit with the emotion because I know that fear has a shelf life, right? It peaks and then eventually it ebbs and then it flows back out just like a wave. And over time, with enough minutes that passed, I felt completely calm. My hand is still right next to the scorpion. And it's this kind of thing where, again, what fear wants you to do is it makes you run away from the emotion. It feels aversive, right? But instead of doing that, what I'm doing is very deliberately leaning into the emotion. And so I'm hoping that over time I can recondition my brain to make, when I fear things, that I take action instead of freezing, right? That's like a 2.0 response to a 1.0 default response. So it's a 2.0 habit upgrade. Taking action in the face of fear or anxiety is like a 2.0 system, basically, or rewiring that you've done in your brain that is not the default. The default, of course, is to freeze. But it's this kind of rewiring process again and again and again that, of course, is what I've been working on in the Deep Change Project, but it's also germane to the article.
Wow, you're kind of dealing with a very old and powerful part of our brains, right? And it's been there to protect us all of this time. This fear response to get us out of harm's way. And I guess what I take away from what you're saying is you consciously you want to bring consciousness to that choice. Like often we don't have a choice because it's just like it happens that instantly. And I guess in certain circumstances that's very beneficial because if you had to stop and think about it and make a conscious decision, well, then you could
It's too
very
late.
well be hurt, or so it's like bringing conscious choice to that situation is a powerful thing. I'm excited to see how you go with that, because yeah.
Well, in conscious choice, as you're describing it, is that mechanism of attention,
Yeah.
which is just to say, the fear wants you to turn your attention away from the danger and just get out of there, right?
Yep.
But if you can consciously choose to turn it back toward it and then allow the emotion to just move through you, or again, in the case of when we feel fearful or anxious, actually creating a habit of taking action, which is what actually institutes emotions like hope, right? Hope is the emotion that, or the emotion that, or the belief that things will get better, right? And of course, the way that things get better is through our actions, not just individual, but of course, collective action. And so, in a sense, hope and fear in this way are pulling against each other, right? Fear freezes, hope pulls us into action. And so, in order to actually make that habit of taking action in the face of fear or anxiety, it's a genuine 2.0 upgrade to your brain.
Yeah, and I guess like leading into your article about neuroplasticity, if like previously, if there's been that action potential in that response, and that was to the fight or flight, and it's created a lasting like neurological connections lasting, then it becomes an unconscious pattern that we have that may negatively pay out in future situations where the threat may be perceived, or the trigger was perceived, but the threat wasn't real, and we find ourselves having a response without it needing to be justified, and the response wasn't justified given the situation. And so, like, in terms of some of the stuff that you talk about in your article, as I read it, I found myself nodding along, agreeing. I'm not a scientist, but I'm someone that's meditated for the last 20 years, and I've come to appreciate how we can shape our reality when we take control of our attention and therefore our brains. And so, like, this is just jumping into the article now. It's like you mentioned in your recent TransTech article that the holy grail of human potential is unlocking neuroplasticity. And put in simpler terms, it's like, how do we get our adult brains to be sponge-like as kids' brains? And you suggest that we know more than ever about neural mechanisms that underlie accelerated brain change by unlocking the dormant potential and reproducing it at scale. That'd be like one of the great feats of neurotech community. So I'm interested to know, like, what brought you to this conclusion?
Yeah, I mean, I think when you look at human potential, in many ways, what we're looking at is neurological potential, right? We're looking at the brain and the nervous system more broadly. We know that brains are inherently changeable. It's one of the deepest kind of core intrinsic properties of neurons, is they're always changing. And we also know that, based on our experience and of course the science as well, that kids are very, very, kids learn languages very quickly. They pick up on stuff. They remember. I mean, I have a 6-year-old right now and a 2-month-old. So I'm just watching the way their brains develop. And, it's crazy. Like my 6-year-olds, it's just crazy what she can remember from, something somebody said 2 weeks ago, and she'll spit it out verbatim. And it's like, how did that just lock in your brain, right? So we know this from experience and the science, and the question, I think, is how do we get kid brains or adult brains to be as sponge-like as kid brains? This is one way that Daniel Chow, the founder of Halo Neuroscience, framed it to me. in a podcast I did with him. And I think he's right to frame it this way because, in a sense, neuroplasticity slows down as we get older. It never stops. Quite the opposite. It's still very, very active. It's just not as accelerated or kind of as intense as it is when we were little. But what we find is that you have direct control over how intense it is. Now, you can turn up the volume again by pulling these different levers in your brain, is how I kind of think of it, right? Michael Merzenich, one of the kind of original neuroplasticity researchers, describes it as turning switches on and off, neuroplasticity switches on or off. And that's a really good metaphor because a lot of what we're talking about happens on the epigenetic level, the level above genetics. So these are actually kind of literal switches that switch on and off certain genes. And so when certain genes are flipped on, those genes make certain proteins that actually instigate changes within a single neuron, growing new dendrites or synaptic terminals or other things that actually change that part of the brain. And so how do you switch those switches on and off? It ends up being one of the questions. And again, in the article, I talk a lot about attention, right? So attention is one of these things that if you can get your head around it and harness it and get good at it as a skill, you not only reap all the benefits, of course, that meditation and mindfulness will tell you that you'll reap, but you'll also increase intrinsically your sort of nascent or dormant even neuroplasticity. It's almost like sleeping potential, right? I often think of human potential as latent, right? That we all have this deep potential inside of us, but we don't necessarily access it. You know, one other quick data point on this is, you know, when you look at neuroplasticity, and again, we're talking about brain change when I say that word, brain change happens in lots of different ways. Lots of different mechanisms account for that type of change. So one of those is myelin sheath. So myelin are they look like sausage links on the trunk of a neuron, the axon, the longest part of the neuron. So they're these sort of like, literally look like sausage links, right? But of course they're made of fat, they're fatty tissue. And they're like insulation for the nerve signal. So the more myelin you have, the stronger and particularly faster the neuron fires. So when you have very poorly insulated neurons, it fires at around 2 miles an hour. When you have fully insulated neurons, and they can get up to 50 layers deep of myelin, you can actually see the myelin rings. The deeper and deeper it gets, it can fire up to 200 miles an hour. So from 2 miles an hour to 200 miles an hour is a big difference.
Wow.
And not only that, but what they call the refractory period, which is how long it takes basically for the neuron to wind back up and fire again, can increase. The speed of the refractory period can increase by 30 times with fully myelinated neurons. So again, it's not actually just 100-fold increase, which is 2 miles an hour to 200 miles an hour, but it's actually 100-fold increase times 30 because of how many times an hour it's firing, right? So it's actually 100 times 30, which is 3,000 times. So you've got this raw processing power of a single neuron from kind of its low end of its potential all the way up to its incredible, like supercomputer potential. And there's a big gulf between those two. And so to access that potential and really direct and start becoming who we're capable of becoming is, again, I think it's a learnable skill set.
Wow, that's fascinating. And so you highlight attention, or you briefly touched on attention there as one of them. You mentioned 6 separate areas in your article as tools or techniques that can increase neuroplasticity, or from what I understand, go from like 2 miles an hour to 200 miles an hour. Can you briefly talk about what the other 5 are?
Yeah, they conveniently spell the word hacks. So attention is the A in the
Yeah.
word hacks. H is for habits. So habits, your brain doesn't care who you are; it only cares what you do. So habits are one of the absolute best levers to pull in terms of, if I want to rewire my brain, what I do every day works its way back into my brain and changes the physical structure of my brain. So if I go for a run every morning, the habit, the portions of my brain that are responsible for those motor movements, and linking those with that timing of the day, with those cues that came right before it, my alarm clock or whatever that looks like, actually is a way to physically rewire my brain. Same thing with attention or meditation.
And is it, we hear the story like 3 weeks or a month is what it takes to actually really cement those neurological pathways. Is that true by your accounts?
Yeah, so Wendy Wood is sort of the lead on habit research, and one of her grad students did a beautiful study and found that habits on average take around 66 days to form. So that's an average. Again,
Yep.
easier habits take a little bit less time, more difficult habits a little bit more. But two months is a good rule of thumb.
Okay, cool. So habits and
So
then
habits, attention, which is again directing, we'll get into attention a little bit more, but it's directing your attention at certain things which makes certain neurons fire more. And so that continued firing essentially demand neurons that get fired get reinforced physically, right? Neurons that fire together wire together. C is for challenge. So basically, brains don't want to sit on a beach and sip margaritas all day. I mean, of course, it's nice for a couple of weeks, but brains love challenge, and there's a lot of research showing that some form of struggle actually increases engagement, and engagement increases neuroplasticity. So challenge is, essentially what kickstarts neuroplasticity is moving outside of your comfort zone into a little bit of a challenge zone. And that's when your brain is actually rewiring itself. So habits, attention, challenge.
Links to some of the research that's emerging around flow as well, needing to not be in stress, and not to be just doing the same thing, but just having that some level of challenge helps to really put us into a state where we can be at our optimum productivity.
Mm-hmm. Mm-hmm. Yep. Perfect example. So habits, attention, challenge. K is for kinetic, which is just movement, right? So this is the biggest link here is actually with neurogenesis. So essentially aerobic exercise and other forms of exercise have deep physical changes in our brain. One of the ways is that it creates a lot more ways that blood can get to all the different parts of our brain. The circulatory system actually grows and expands when we do physical exercise. But you create something endogenously in the body called BDNF, which is a neurotrophic factor, a growth factor. So it creates more new neurons. So our stem cells in our brain basically create new baby neurons at a much higher rate when we do things like aerobic exercise.
Cool. So kinetic.
So that's kinetic. And then S is for stress reduction. So another way of saying this is brains don't change that much when they're stressed. Brain wants to hold on to the status quo when it's stressed, because stress means danger, and danger means I want to get back to familiarity. Familiarity means hunker down, protect. Don't have time for those building projects. That's when I'm feeling safe and calm. And then the last one is actually, in addition to the hacks, which is this kind of element of positive neuroplasticity. So there's a lot of good research showing that the brain changes best when it feels good. So there's a certain BJ Fogg and others have been showing that lots of things like celebrating, for example, after we finish a habit ends up increasing dopamine production, or a little sort of squirt of dopamine, which fuses. Dopamine has a really interesting role in this moment, which is it fuses the cue or the trigger that came right before with the behavior. So basically, habits form more quickly when you celebrate, among other things.
I was just going to say, so what you've kind of gone through there is reinforcing a lot of the gold standard positive psychology stuff that I've been learning around for over recent years. And like gratitudes, I guess, is a means to hack that celebration, like feeling that sense of positive well-being up front as you're thinking about, as you're putting your attention to the thing that you want to have formed as a habit or show up in your life. And as much as you can bring in your other skill sets, like I know for me, like I write out my big goal every morning and every evening because I'm activating the kinesthetic aspect of that. I'm putting my attention to that. I'm linking that to the gratitudes as I'm doing this as well. Yeah, it's kind of reinforcing a lot of the gold standard positive psychology stuff that you're suggesting, that showing the science of why these things work, which is really exciting.
Yeah, building projects are expensive. Changing the brain, it's an expensive activity. And so when your brain and body feel safe and feel calm, grateful, gratitude, all that stuff's bringing in those types of emotions, then your brain can move into those sort of building activities that it does.
Yeah, nice. That's a good analogy, good way to look at it. So I understand your intention is to write articles on each, do a deep dive into each 6 of those hacks, those different tools to help build neuroplasticity. This particular article, we did a deep dive into attention and how that is linked to neuroplasticity. Can you talk to us a little bit more about that?
Yeah, for sure. So attention is, attention is like a, there's lots of different metaphors for this, and the brain actually helps it think better when we use metaphors. Mm. But to think of it like a spotlight or a laser beam, attention is the ability to focus on one thing and essentially ignore other things. To zero in on something, to pay attention just to that thing and let other things let them go. This ability basically, or the kind of capacity to do this really well, and means that you're able to tell your brain what parts of it should be working right now. And so as you do that, so let's take the example of reading a book. So if you're fully absorbed in that book, let's say you're in flow and you're really into it, right? You're locked into that book. Now, there's ambient noise going on. There's a truck driving by, there's birds chirping, there's random stuff happening around you. But if you're fully absorbed in the book, whatever ideas or words that you're actually reading right then, because your attention is really engaged, you're just simply going to remember better. And if you're also simultaneously not only just paying deep attention to it, but you're also linking it to things you already know, then you're going to, the memory we have for that type of information that we're intaking is going to be much higher. Now, the reason for that is purely attention, right? When we forget things or we don't remember things later on, it's usually not a recall problem. It's usually an encoding problem. It didn't go in well. It didn't, when we were, if somebody tells us something and we say, yeah, I'll get that. But our mind is kind of somewhere else, and we forget to pick something up at the store, say from a partner or spouse, and we get home and they're like, so did you get it? And we're like, oh shoot, I forgot. And of course we remember right then that they'd mentioned it, but we just obviously forgot. Generally speaking, that's not because we forgot, it's because we didn't encode it. And because we weren't actually paying attention when they said it and getting it in, or, you know, the next logical step would be setting a reminder on our phone to reinforce that memory. But attention works like that.
And sometimes it's easier said than done, like holding our attention, like as a meditator, or as anyone that's meditated, when you sit and attempt to meditate, it's very quickly that you learn how little control we have actually over our attention. And so it is a practice, right? And I feel like meditation is a great tool for that. Coming back to like where we started our conversation with the scorpion story, though, it's kind of like there's so many things competing for our attention, or even unconscious programs and patterns pulling on our attention. And if we've got these unresolved emotions that are drawing on our attention, then it makes it so much harder to actually, in that unconscious, it makes it so much harder to be able to hold our attention. So by applying like it's almost like diffusing that situation with that scorpion with your, you know, your awareness in that situation, it's likely to then not be one of those unconscious programs that plays on our attention. Because I look at it like holding your attention, there's just all these little thoughts and things that are like the truck going past may be a trigger, or for whatever reason, maybe you nearly hit by a truck, that are pulling on our attention. So it's multifaceted is kind of what I'm saying.
Yeah, no question. Yeah, no question. And for this reason, I read with earplugs most of the time.
You what, sorry?
I read with earplugs most of the time. And the reason is because I don't want 25% of my attention scattered by ambient noise. You know, that this kind of a thing, these are little hacks, but they end up because of things like an orienting response. We orient to noise automatically and unconsciously, right? It's just continuously drawing off a little portion of our attention. So that means we're not remembering as well what we're reading. Because again, when you're encoding knowledge, or when you're paying attention to something, you're making those particular neurons responsible and probably newly responsible for that new information. You're making them fire more. So as they fire more, they then basically tell the brain, all right, these ones that fire need to get reinforced. So there's more myelin wrapping that happens. There's more usually dendritic and synaptic terminal growth. So new. And we can get into this if you want. Basically, it starts out as short-term memory, which is really a chemical change between synapses, which then over time translates, if you hold something in memory long enough, or that thing kind of deeply enough, basically you get you get the production of some proteins from the nucleus that actually tell the neuron to actually form new branches. So again, I'm just going to zoom out here. Neurons look like trees, right? So if you were a giant, you could go outside and rip out a tree and turn it sideways. That's what a neuron looks like effectively. So thousands of branches, 5 to 10,000 branches, big long trunk in the middle, and then roots at the end. So the branches are dendrites, the trunk is the axon, the roots are the synaptic terminals. So it goes down the axon and out the roots. That's usually the direction a neuron fires. So when you're encoding new information, in the beginning, you have this little change between synapses. So those branches reach out and touch other branches of a neighboring neuron, right? They don't quite touch. There's actually a synaptic gap between them, but they're literally like this, right? That's how they talk. This is how the neurons talk to each other. So in that gap, in the beginning, is where memory starts to form. This is Eric Kandel's work. So originally, you have like a chemical change where it's called long-term potentiation. So essentially, you have like a increased ability and sort of activation of those neurons to each other. And this can last anywhere from Originally the research showed, a few minutes to 10 hours. And now we know that long-term potentiation can actually last for days or even weeks. So a lot of some memory theorists believe that this is what short-term memory is, right? Long-term potentiation. It's a chemical change at the level of the synapse between neurons. Now, if that's held, so think of this, right? If you're paying attention to an idea for long enough and deeply enough, basically you're signaling to the brain, wow, this is really important. Like I want to remember this. You're paying attention to that information. As you keep paying attention over time, you keep revisiting it. Later that night, you're thinking about it again. You're thinking about it in the shower. You keep going over that piece of information because it's so fascinating to you, right? Eventually, that chemical change sends enzymes back up in the nucleus to activate CREB1, which is CREB1 is basically a protein that activates on part of the genome to then start the building process, to actually build new connections or new branches, in this case probably roots, to that neighboring neuron. So that long-term, so there's functional change, which is short-term memory, generally speaking, right? And then there's structural change, which is that the neurons actually physically grow new branches. I'm oversimplifying it a little bit, but that's the basic idea. So that transition from short-term to long-term memory is usually from a chemical change to a physical change where the neurons grow new branches. And as they grow new branches, some memory theorists think that a new dendrite is responsible for a unit of information. We don't quite know this, but it makes sense from how do neurons hold information, because it correlates with the physiological underlying kind of structures of how neurons change when learning new things. And so attention is what holds that thing in short-term memory basically long enough and intensely enough for that long-term memory activation to start taking place. And so what was just a functional change or a change at the synapses becomes a structural change over time. And that's when you genuinely see long-term changes and you become different, or you learn a new skill, or you learn new information. This is one example of how attention affects neuroplasticity.
What I love about this is attention is our conscious choice of what we actually want to encode into our brain in terms of what will become habits, where a lot of this, particularly in our younger years, has just happened to us. So we didn't have any conscious control over it. So it's with this new knowledge, and I love what you're sharing. It's our ability to be able to say, well, this is what I want to see. This is how I want to change my brain so that it works for me. So love it. You mentioned earplugs. That's kind of like a low tech solution to help take control of our attention. Interested to know other sort of hacks that you have in that low tech space, but then I want to get us into sort of more talking around like modern technologies that you see that can help us to effectively take control of our attention. But any low tech other hacks that you use to help guard your attention at the moment?
Yeah, don't rely on willpower to resist checking Facebook, for example, right? Rely on technologies to prohibit you from checking it during the times that you don't want to check it, right? So I use an app blocker, a website blocker called Freedom, that just, again, I go to search the news or something in the middle of my workday, which I really probably don't want to do, and it comes up with this nice green screen with a big butterfly and says, you are free from, the New York Times or whatever. Go take a breath or go enjoy your free space. So the first thing is don't rely on, you got to design for focus. It doesn't have, the opposite is what happens naturally, because there's such a competition for attention, right? So many business models are built around grabbing and hijacking your attention.
Yeah, making it addictive and yeah.
Yeah. So you've got to pretty deliberately kind of push back against that and design for focus. You can't, if you don't design for focus, you're essentially by default designing for chaos. And so this is so that's number one, is use an app, use some sort of website blocker and schedule that out, I think, with your digital life. The other thing is design for non-distraction, right? Find spaces. This is obviously hard during the coronavirus situation for a lot of people who are quarantined, right, and staying home. But even if it's for small blocks of time, right? Trade off if you have kids or you know, have a partner or spouse, just find ways to negotiate with each other to have blocks of uninterrupted time in a physical location that's separate from the rest of the crew. An hour, 2 hours, that kind of a thing. That's going to allow you to dive deep and not be interrupted. Interruptions are terribly problematic for knocking us off of flow. And the other thing is, yeah, just low tech is. I mean, these are obviously technology related, but silence. All my phone is always on silent. No, keep your email closed. Some studies have shown that if your email is open, it lowers your IQ by 10 points. Just the fact that it's open and staring at you, because it's like an open loop and your brain is siphoning off part of that attentional capacity toward managing that open loop, even though you're not dealing with it actively. All these types of things really do make a difference on our attention.
Great, I love it. A lot of those I implement in my waking reality as well. So tech, what are some of the text, like as part of your article, you list a whole bunch, like including meditation apps, neurofeedback devices, transcranial direct current stimulation. Can you chat us through a couple of examples of these?
Yeah, I think the meditation apps, let's start there because I think everybody's familiar with that space. I think the unheralded kind of benefit of meditation apps is their neuroplasticity enhancers, along with, again, all the deep relaxation that comes with meditation, the deeper kind of mental training and attention and awareness raising that the meditation does for you. I use Headspace every day, you know, so that's it's I guess any meditation app you use is going to increase that attentional, your ability to direct your attention at what you want it to be on. And as you increase that capacity, you're essentially becoming an accelerated learner, because when you are learning or paying attention to something, you're actually really paying attention, deep attention to that thing. And so indirectly, you're just going to have a better memory. And in the meditation research, this has been shown many times where people increase their memory capacity. So that's I think an interesting place to start. I think in the neurofeedback space, this is
Just quickly with the meditation apps, there's a whole host of different ones, like you mentioned. Headspace, Calm is another one. 10% Happier is another one. There's like literally hundreds of them now emerging, but there's a couple of big players in the transformative technology sort of space, isn't there? I think what's the number one is Calm is top of the tree at the moment, is it?
Calm seems to be, Calm has the kind of strongest valuation.
Yeah. Okay.
And so if you're using that as the benchmark, they're probably the leader. But Headspace is those two really are the leaders. Yeah.
I guess user base as well. And they all have, I've sort of did a bit of backstory on all of them. Some of them, I think, is it Calm has the founder, he does all the meditations, whereas Headspace has a range of different teachers. And I know Insight.
Opposite. Headspace, Andy Pettycombe does all the meditations.
Got it.
That's it.
And then Insight Timer is a range of different teachers. I think they've got thousands of different teachers to choose from, different variety of applications. So if someone's looking to get into meditation, these are a very inexpensive and soft landing into learning and meditation practice, right?
Absolutely. Absolutely. Yeah, and they each have different experiences that go with them, but the broad benefits of each of them is quite similar. Meaning you don't worry too much about which one you're choosing. Obviously, go with the one that you find is you're liking the most and is the best user experience for you. But you're going to be getting a lot of the same benefit, depending, not indifferent of which one you're going with. Generally, most of them, and again, there are deeper nuances here, depending on the type of meditation. But a lot of the ones that are doing mindfulness meditation end up giving you a lot of the same benefits.
Great. So you're moving on to neurofeedback devices. Tell us about some of those.
Yeah, so neurofeedback is just a way of holding a mirror up to your brain. In other words, the brain often can't see what it's doing. So when you hold a mirror up to the brain by showing it what it's doing, it can learn to self-regulate based on what it sees itself doing. I know that sounds sort of circular, but let's just talk about Muse because they're kind of the leaders here. So Muse is a meditation headband. You wear it while you're meditating. It's measuring your EEG, your electrical activity in your brain using EEG technology. And basically, it's through a process of auditory feedback telling you when your brain is kind of in a calm, focused state or a mind-wandering, distracted state, roughly speaking. So the feedback you get is when it's calm and you're in that kind of, zenned out place, let's say, you hear birds chirping. But when it's in that kind of distracted or mind-wandering state, you get the sounds of like thunderstorms. So that kind of feedback is a way of highlighting to your brain, oh, when you're hearing the birds, you're doing what I want you to do. So your brain can see what it otherwise usually couldn't see as clearly. Whereas again, when it's in the thunderstorm kind of area, we're telling the brain that you don't necessarily want to be there. So in a way, it's a way of, you could think of it as reward-based learning. You're giving the brain a little bit of a reward when it's doing what you want it to do. But the
of entrainment here, like Pavlov's dog, kind of where the brain learns when it is consciously learns when it's in a good state. So you've got that conscious recognition of this is what we want it to be. Because I know for me, like for example, I use a focus band, and I find myself getting a little bit too drawn into my computer when I'm working, and I was like, then I check my breath and realize that I'm breathing short and sharp and starting to lose my flow. And if I put on my EEG device, my neurofeedback device, and then set it to a flow setting, then unconsciously or unconsciously, I'm listening for that neurofeedback, that auditory feedback to let me know when I'm in that state. And for me, then I've automatically find my breath is deepened. So I'll be working and my whole physiology is changed because my brain is looking for that auditory feedback while I'm working, and my productivity goes back up, and I'm no longer feeling anxious or overwhelmed. So it can be really quite powerful.
Yeah, no question. No question. So so biofeedback or neurofeedback ends up having this exactly as you're describing. It tells you how you're doing, and then you self-regulate or change something depending on what that feedback looks like, very naturally. we self-regulate all the time with just added information. Like if you're speeding, for example, down the road and you see a little speed meter, electronic meter, it's not a cop, it's just a sign, right, telling you how fast you're going, and you realize that you're going faster than the speed limit because of the, real-time feedback, you just naturally hit the brakes.
Yeah.
You don't even think about it, right? And so it's the same kind of a thing where when you start realizing that you're really distracted or you're not breathing as deeply, you naturally start breathing more deeply because you have extra information that you're then working on, which you didn't have, or that information was more murky before.
Yeah. Again, it just brings our attention to it as
Yeah.
well, like, so that we can make the change.
Yeah, absolutely. Yeah,
Um,
and then the third, do you want me to talk about the transcranial?
yeah, please. Yep. That'd be awesome.
So then there's lots of, I outline in the article, lots of different players and emerging players in all these different spaces. So please take a look at all those. There's some really innovative stuff going on in each of these spaces. What transcranial is really one that I'm finding particularly fascinating right now. It's transcranial direct current stimulation. So this is essentially mild electrical current that, when you say trans, it goes across the cranium or the skull, right? Transcranial. And into the brain. So this is something that there's been tons of research on this over the last, decade plus. And we're finding so far that it's incredibly safe. In the past, there were much kind of cruder forms of this, electrically stimulating the brain in the 20th century. It was much more harsh and much more uncontrolled, and we had much kind of inferior technology. But now we've really gotten good at understanding how to do this safely and how to do it in a way that amplifies neural firing. So the company I highlight in one of the companies I highlight in the article is Zendo, and they're building, or they've built, and it's now to market, or just literally like in the last month or so, their product, which is you put it one patch right here and one patch sort of on the side of your head. And those patches are, they have a gel substance, but they're basically just creating a kind of clear contact with your head, and they're emitting a certain level of direct current stimulation. That current stimulation is activating certain parts of your prefrontal cortex in a way that those same parts would probably be activated, or some form of that, through regular meditation, but it's enhancing or deepening that effect. And so it's acting directly on the brain is the difference, I think, with transcranial direct current stimulation, as opposed to neurofeedback, which is you're changing what you're doing. It's not acting directly on the brain, right? This is, again, what's interesting. I thought this was really interesting when I talked with the founders of Zendo, that you don't, in order to have those sort of relaxing and effects to stimulate those parts of the brain, you don't necessarily need to be meditating. But they suspect that when you're doing it in that way, you're both meditating and doing it, it may be an enhanced effect. But basically, again, this is taking the principles we know about how neurons learn, which is when you're, again, thinking about attention, when you're paying deep attention to something, the neurons in that area fire more quickly and more, and just simply more. And so it's that same type of experience through an added technological, piece, where you're just getting a kind of accelerated learning curve on, let's say, a meditation practice, or a kind of executive functions that your prefrontal cortex is responsible for.
Yeah, cool. And I've seen the transcranial direct current stimulation is used in conjunction with the neurofeedback devices, just so you can actually see how the direct current is actually influencing the different brainwave states. It's all very interesting. It's such an exciting space. And do you feel like there's like it seems to me like now more than ever there's an opportunity for us to use these technologies to really, and I guess this is to a large extent what you're all about, is brain by design, is teaching people how to take control over their brain and make it work in an optimal way. Like Transtech, transformative technologies, we're about supporting entrepreneurs and innovators to build technologies across these sectors. So for people watching this, like this, I guess my question is, this is an emerging space. Would you suggest, like, for people to consider moving into building technologies, building solutions to help us more effectively optimize the brain and its neuroplasticity?
Yeah, you're asking if it's a kind of space that people could be moving into. I'm not totally sure on the question. Say one more time.
So that is the question. Like, essentially, I guess when I look at this from a transformative technology lens, we're about building a community, a support structure for innovators and entrepreneurs. And I see this as a growth area, like something that it makes sense for people to consider building solutions in. And I guess was just after some sort of validation from you, if you also agree that this is something that is going to grow moving forward, our ability to be able to take control.
Yeah, no, I think this is one of the most exciting areas of neurotech, which is to accelerate neuroplasticity, right? Because once as we get better and better at this, what you're starting to see is our potential, like human potential, we know is enormous. And we know also that most of us are living below that potential. And so as you turn up the volume of potential, that's what the opportunity I believe is we can become these better versions of ourselves, right? These, when you think about who, when you think of your sort of ideal version of yourself, who would you like to be in the world? This is within reach, and it's not that the technologies will be the only way we'll get there or going to save us from ourselves in a sense. I don't necessarily think that's the case. I think they will augment our inherent capacity for growth and development. I think we will, again, you can't, I don't necessarily think you can take someone who's not doing the kinds of things that you're doing, which is have a meditation practice and a whole host of other things you're doing to take care of yourself, eating, exercise, kind of these foundational pieces in your life, and make them a superhuman. I don't think that's really how it works. I think you've got to kind of build all those life factor habits and foundations. And then as you build that good foundation, you can start increasing your ability to again become who you want to be. And that's going to look a little bit different for everybody, right? Some people want to work on their empathy and be a more empathic or loving person. Some people might want to really zero in on focus and ability to really manage that attention. Other people's want to work on their joy or their ability to just inherently and intrinsically feel like a happier person. They want their happiness set point to be higher, right? And so these goals are going to vary by person, but when you think about who is the 2.0 you that you want to be, that's, I think, what we're unlocking with these types of technologies.
Unlocking that latent potential that we be, and that's going to be different for everybody. That's exciting. It really is. I did have just a little section of the article that you wrote. I just wanted to read, so bear with me while I read through it, because I think is a good little summary for us to finish on. I really appreciate the opportunity to chat with you, man. I've learned a whole bunch and reinforced a whole bunch more. So thank you.
Yeah, you're welcome.
But so you say in concluding your article that as the groundswell of interest in neuroplasticity continues to grow, and we get better at understanding how things like attention affects neuroplasticity, more and more people will want to know how they can harness attention and accelerate brain change. They'll be hungry to get better at Professor Jeffrey Schwartz calls self-directed neuroplasticity. What then? Will it look like to think of neuroplasticity as a learnable skill set? What will it mean to become a neural designer? And as we get better at shaping our own brain, or of becoming our own neural architects, who will design the technologies that will help us get there? I think it's safe to say these companies are off to an impressive start. So that kind of just reinforces the question that I asked before. Like, this is an exciting space. We're moving into this incredible era. And Nicole Bradford, one of the founders of Transtech, she talks about, you know, how our crises and our technology have gone on, hit this exponential curve, but our humanness is still on this linear curve, and it's applying those technologies to applications like self-directed neuroplasticity, becoming a neural designer, that we really enable us to step into being a greater expression of our individual potential. And for me, man, that's really exciting. So I really appreciate you, and I really appreciate the work that you're doing. I'm thrilled that you're our thought leader for, you know, psychology and behavioral economics for transformative technology. Really excited to see your next article. Hopefully, I'm hoping it's going to be a continuation of the other of the 6 areas that you mentioned around neuroplasticity. Is there any final comments or anything you wanted to mention before we wrap up this particular call?
I think the thing that's exciting for me is this is doable for anyone. You know, I think people get outside of the kind of tight neurotech community, you know, going to the Transtech conference, these types of things. I think it can feel a little intimidating, you know, for people with neurotech and this and that. And again, you forget that it's a small world, that neurotech, you know, ecosystem. It's a small world. And I'm thinking about the implications for the broad world, right? I want to be talking about neuroscience and brain science in a way that my bless her heart, my grandmother, my passed away grandmother, could understand, right? Like that's the level on which I want to be communicating the science, and I want it to be accessible to people, right? Because it serves no one if people feel intimidated, I think, by this kind of stuff. And what I'm hoping comes through is that this isn't, it's not as complicated as it might seem, number one. And number two, these are just learnable. This is just a skill set, like learning to play the piano. You know, it just takes some time and a little bit of effort and understanding a handful of basics for how your brain works, which again is pretty understandable. It's like Judson Brewer, who I've been following a lot because he's doing a lot on anxiety right now with coronavirus. And he says something to the effect recently on a podcast that the more I study this, the simpler it gets. You know, which is just to say that the way that the brain and body work, when you understand it, you know, it doesn't have to be that complicated. It's actually quite accessible. So self-directed neuroplasticity, those are big words. I actually think those aren't the best words for it. I think we can come up with a better way to message that. So if anybody has any ideas for that, I'm totally open to that, but that's sort of the best formulation I've heard of it so far. This is a skill set, learning any other skill set. So it's not, it's very much within reach of everyone.
How about brain by design? That's a pretty cool name.
That's a good one. Yeah, I like that one. I think I'll use it.
Yeah. Thanks so much, James. Great final remarks. Again, thank you for taking the time to
You're so welcome.
That now and do a deep dive into your article. And thank you for taking the time to bring your intellect and your thoughts to paper and produce the article that you did. I really enjoyed reading it. if anybody hasn't taken the time to check it out, Neuroplasticity 2.0, Enhancing Brain Change. It's on the medium.com, Transformative Technologies publication. Check it out there. And yeah, thanks again. I look forward to our next interview.
Yeah, thank you. Appreciate it, Troy.